In this video, we are covering 10 of the chapter 21 exercises. As you go through the video, you may want to pause the video after the question appears, answer the question on your own, and then check the answer in the video. First three questions are related to the reaction sequence shown here. And to answer those questions, of course, it's a good idea to first read the questions, but you will have to know the reaction sequence anyway. So you may want to complete this reaction sequence on your own. You know what is compound A, and so you need to find out what are compounds B, C, and D. First step, conversion of compound A to B, is reaction of parabromotoluene with lithium in hexanes. That reaction is halogen metal exchange of bromine with lithium, and product is corresponding phenyl lithium. Then next reaction is reaction with copper iodide, a salt. This is a transmetallation reaction where lithium is replaced by copper and product is corresponding lithium dialkyl cuprate. Finally, the reaction with another equivalent of compound A is a coupling reaction of lithium in this case diphenyl cuprate, with another equivalent of parabromotoluene, and this biphenyl compound D is obtained. So this completes reaction sequence, and now we can examine three questions that are related to that sequence. First one, compound C is formed in what type of reaction? I already mentioned that reaction is a transmetallation reaction. Next question, question number 2. What is the role of substituent CH3 or methyl group in the reaction sequence? If this were electrophilic aromatic substitution, methyl group would have been activating substituent. But this is not reaction on benzene ring, so in this case methyl group has no effect. So correct answer is D. Question number 3. What is the formula of the compound D? Well, if you completed the sequence, you already figured out that D is a biphenyl, and then you need to match that with one of the 4 possible choices, and it matches compound B. Next question, which of the following is the product of the series of reactions below? So you have a bromoketone that is treated first with methanol in the presence of an acid catalyst, then magnesium in ether as a solvent, then formaldehyde, and finally acidic workup. The best way to answer this question is to write down reaction sequence below. And it's a good idea to write organic compound as a line formula, then it's much easier to see reactions or organic transformations that are occurring. So first step indicates here just as one, so you don't have to rewrite all the reagents and conditions, is simply formation of a ketal. So methanol in the presence of an acid catalyst reacts with carbonyl to produce corresponding acetal or ketal, in this case ketal. Next step, reaction with magnesium in ether gives corresponding Grignard reagent, and now you can see the reason why preparation of ketal was necessary. To protect carbonyl, otherwise as magnesium bromide is formed, it would react intramolecularly with carbonyl group. Next step is reaction with formaldehyde, so that's extension of carbon chain by 1 carbon atom with formation of the corresponding alkoxide. And finally, acidic workup both protonates the alkoxide and removes protecting group, converts ketal back to ketone. We need to name this compound, and so you can see that this compound has 6 carbon atoms, so it's hexanon. On the second atom there is carbonyl group, so it's 2-hexanon, and finally on carbon 6 there is hydroxy group, so it's 6-hydroxy-2-hexanon. Next question, Which of the following is not a correct structure of a Wittig reagent? When you consider structure A, you can see that it contains both carbon-phosphorus double bond and charge separation, free electron pair and negative charge on carbon and positive charge on phosphorus. That's actually hybrid structure of two correct structures of Wittig reagent, but that one is not correct because it's hybrid, a combination of two correct structures. So A is the answer to this question because that's not correct structure. Correct structure is B, and you can see in that structure we have charge separation, carbon-phosphorus single bond, negative charge and free electron pair on carbon and positive charge on phosphorus. Or alternative resonance structure is structure C without charge separation and carbon-phosphorus double bond. So either B or C are correct structures, but A, which is combination of the two, is not. And finally, D is structure of a stabilized Wittig reagent. So correct answer to this question is A. Question number 6. Which reaction sequence will accomplish the following transformation? To answer this question, you may want to use pen and paper and go step by step, but still even a simple consideration of offered choices should be enough to figure out correct answer. So this is conversion of an aldehyde into tertiary alcohol. That means that we need to add two alkyl groups in form of organometallic reagents. That means that reaction is going to occur twice. So first choice, answer A, lists methyl lithium in hexanes and then acidic workup, but acidic workup is not separate. Under first step, under 1, we have methyl lithium, hexanes, acid and water. That would be an indication that everything is mixed together. And of course, since methyl lithium is not compatible with an acids or water, this is obviously wrong answer. Really under 1 there are 2 steps that have to be listed separately as 1 and 2. For that reason you can right away eliminate answer A. Simply notation is not correct. We are not correctly indicating steps that are occurring. B, we have PCC oxidation. Aldehydes are prepared in PCC, pyridinium chlorochromate oxidation of alcohols, primary alcohols. So this is step to prepare an aldehyde, but starting material is already an aldehyde, so obviously this is not an answer. Answer C, we have methyl magnesium bromide reagent, followed by acidic workup. That looks correct. Methyl magnesium bromide, upon addition to this aldehyde, cyclohexane carbaldehyde, would give corresponding secondary alkoxide, which upon protonation would give secondary alcohol. And then PCC oxidation would convert that alcohol to a ketone. And then addition of ethyl magnesium bromide followed by acidic workup gives the product. Desired product listed here. So C appears to be correct answer. D, just to make sure, is not correct because PCC oxidation should occur after the first addition of Grignard reagent. In this case, we have first addition of Grignard reagent, acidic workup, and then addition of ethyl lithium. Well, that wouldn't do anything. It wouldn't react, or it would react with secondary alcohol that is produced, but that alcohol that would simply protonate ethyl lithium and produce ethane. So that's obviously not correct answer. So correct answer is C. Note when you compare A and C that they are almost identical. The only difference is in notation, that we have correctly listed 5 steps that are needed to convert cyclohexane carbaldehyde to tertiary alcohol, while under A those are presented as 3 steps incorrectly. Question number 7, what is the name of the following compound? So hopefully you can recognize that this is a phenol, phenylketone, a phenol. And so you look what is the substituent. So on phenylketone, substituent is benzene ring, which together with carboxylic group would form benzoic acid. So we name it benzophenone. Remember, we drop IC from the name of the corresponding acid and then use suffix phenone. So that's benzophenone. Question 8. What is UPAC name of the following compound? This is a ketone and there are 6 carbons, so hexanon. Carbonyl group is on carbon 3, so 3-hexanon, and then we name the rest accordingly. So it is going to be 5-bromo, 4-hydroxy, 3-hexanon. Question number 9. Provide formula of the product of reaction of propanol with phenyl magnesium bromide, followed by an acidic workup. It's best to write down propanol, 3-carbon aldehyde, plus phenyl magnesium bromide. Obviously that's going to give corresponding secondary alcohol or secondary alkoxide, and then followed by acidic workup corresponding secondary alcohol, and here is the formula. Finally 10. Provide formula of the product of reaction of propanol with phenylhydrazine. So here is propanol with phenylhydrazine, so product is corresponding phenylhydrazone. And this completes this short set of exercises related to chapter 21.